guys, welcome to my channel Chem Live. So today we will discuss about microstate and term symbol. Now the microstate is defined as the different arrangement of electrons in a set of orbitals has slightly different energies, and it's called as the microstate. So to find the microstate, the formula is for the microstate. The formula is n factorial upon n minus r factorial and r factorial. If you are familiar with the term factorial, then it's alright, and if you are not, then let us clarify this by taking an example. So we have P2. So for finding the microstate, for finding n, we have to take the total number of electron, the maximum number of electron that can be filled in the p orbital, that is 6, and it can also be called as the double of the number of orbitals. So p has px, py and pz, so double of 3 is 6, so that is n, and r is 2, so n minus r is 6 minus 2, that is 4. Now for the microstate, n factorial upon n minus r factorial upon n r factorial. So n factorial is 6 factorial upon n minus r, that is 4 factorial upon 2 factorial. We will write the factorial as 6 into 5 into 4 into 3 to 2 and 1 upon 4 into 3 into 2 into 1 and 2 into 1. So 2 into 1, this is cancelled out. So 4 to 4 and 3 to 3 and 2 to 6, 5 3s are 15. So for P2 the microstate is 15. Now let's take the other example of P3. So finding microstate for P3, we have n factorial upon n minus r factorial and r factorial. So n for P is 6, as we have already discussed, and 6 minus r, that is 6 minus 3, r is 3, that is given. So 6 minus 3 is 3 factorial and r factorial, that is 3 factorial. We can write it as 6 into 5 into 4 into 3 factorial upon 3 factorial multiply 3 into 2 into 1. So this is cancelled out. 3 2s are and 2. So this is 20. So microstate for P3 is 20. After discussing about the microstate, let us discuss about the term symbol. It is used to indicate the electronic configuration and the resultant angular momentum of an atom. It is just another representation of the electronic configuration. So term symbol can be represented by the general formula 2s plus 1 L and G. Here S is the total spin angular quantum number and L is the total orbital angular quantum number and J is the total angular momentum quantum number, and 2s plus 1 is the spin multiplicity. Now let's take an example to clarify this. So we have P2. For finding the term symbol, we have to write this as 1 and 2. The m is plus 1, 0 and minus 1. Alright, so for finding s, we have n by 2 formula. Here n is the total number of electrons, and this is 2 by 2, and this is 1. So 2s plus 1 is 2 into 1 plus 1, that is 3. Alright, for finding L, we have to multiply this as plus 1 multiply 1 plus 0 multiply 1. This is 1. So L equals to 1 corresponds to P. So we know that L equals to 0 for S, L equals to 1 for P, L equals to 2 for D and 3 for F. So L equals to 1 corresponds to P. Now to find J, we have L plus S modulus to L minus S modulus. Here L plus S is 2 and L minus S is 0. So this is 2, 1 and 0. We will take the value of J, that is the lowest, because we have here less than half filled electronic configuration. If we have less than half filled electronic configuration, then least value of J is to be taken. So the least value of J here is 0. So we have the term symbol for P2. The term symbol is 2s plus 1 L and J. We can write it as 2s plus 1, that is 3. L is P and J is 0. So 3P0 is the representation of term symbol for P2. Let's take the other example, that is D1. We will find its microstate as well as its term symbol. So for microstate, the formula is n factorial upon n minus r factorial and r factorial. So here the d orbital has n equals to 10, as it contains 5 orbitals and the double of the number of orbitals corresponds to n. So we have 10 factorial upon 10 minus 1, r equals to 1 here. So 10 minus 1 is 9 factorial into 1 factorial. So this is 10 into 9 factorial upon 9 factorial into 1. So this is cancelled out and 10 is the microstate for D1. For term symbol, we will write as this, and m value is plus 2 plus 1, 0 minus 1 and minus 2. So S is n multiply plus half, that is 1 multiply 1 by 2 equals to 1 by 2. So 2s plus 1 equals to 2 into 1 by 2 plus 1, that is 2. Now L equals to 2 into 1, here 2 into 1, that is number of electron, equals to 2. So L is 2 for D, as we have discussed earlier. Now the J equals to modulus of L plus S to L minus S. Here L plus S, 2 plus half to L minus S, that is 2 minus 1 by 2. This is 5 by 2 to 3 by 2. Alright. So we will take the value of J, that is the lowest, because here we have the less than half filled electronic configuration. So the term symbol for D1 becomes 2s plus 1 L and J equals to 2s plus 1, that is 2, and L corresponds to D and J, that is 3 by 2. Now we will find out the term symbol and microstate for D5. So we have for the microstate the formula n factorial upon n minus r factorial and r factorial. Here r is 5 and for d n equals to 10. So the microstate is 10 factorial upon 10 minus 5, that is 5 factorial and 5 factorial. So this is 10 into 9 into 8 into 7 to 6 and 5 factorial upon 5 factorial into 5 into 4 into 3 into 2 and 1. So this comes out to be 252. That is the value of microstate for D5. Now for finding the term symbol, we have this 1, 2, 3, 4 and 5. So we have plus 2, plus 1, 0, minus 1 and minus 2, the value of m. So S, that is n into half, that is 5 by 2. 2s plus 1 equals to 2, 5 by 2 plus 1, that is 6. Alright. Now L equals to 2 into 1 plus 1 into 1 plus minus 1 into 1 plus minus 2 into 1, that is 2 plus 1 minus 2, all cancel out and it come out to be 0. So L is 0. For S, as we have discussed earlier, J, that is L plus S modulus to L minus S modulus. It is L plus S, that is 5 by 2 plus 0, that is 5 by 2, 2, 0 minus 5 by 2, that is minus 5 by 2. Now the term symbol for D5 can be written as 2s plus 1 L and J. Here the value of 2s plus 1 is 6. So we will write 6 and L is S as we have found. And we have two values of J, that is 5 by 2 and minus 5 by 2. Here we have the half-filled electronic configuration. So we will take both values, the 5 by 2 and minus 5 by 2. So this and this. Alright. So D5 can be represented by both these term symbols, 6s 5 by 2 or 6s minus 5 by 2. Now for D8, the microstate can be calculated as n factorial upon n minus r factorial and r factorial. So we have 8 factorial upon 8 minus. So we have 10 factorial upon 10 minus 8, that is 2 factorial upon 8 factorial. We'll write it as 10 into 9 into 8 factorial and 2 factorial and 8 factorial. So 2, 5 and we have 45, that is the value for microstate. Now term symbol for D8 can be calculated as 2s plus 1 L and J. Firstly we will write it as 1, 2, 3, 4. It's 1, 4, 5, 6, 7 and 8. That is plus 2 plus 1, 0, minus 1 and minus 2. So S is 5 multiply plus half plus 3 multiply minus half, as 3 electrons are of opposite spin and 5 electrons are of same spin. So we have 5 by 2 minus 3 by 2, that is 1. So S is 1, hence 2s plus 1 is 3. Now the value of L can be calculated as 2 multiply 2 plus 2 multiply 2 plus 1 multiply 2 plus 0 multiply 2 and plus minus 1 multiply 1 plus minus 2 multiply 1. This is 4 plus 2 minus 1 and minus 2. Minus 2 and plus 2 are cancelled out and we have 3. The value of L is 3 and it is for F. Now the value of J, that is modulus of L plus S to L minus S, and so we have 10 into 9 into 8 factorial and 2 into 8 factorial. So this is cancelled out as this and we have 45. The value of microstate. For term symbol, we have 2s plus 1 L and J. So first we will make it as 2, 3, 4 and 5, 6, 7 and 8. So plus 2 plus 1 0 minus 1 and minus 2. So S is 5 multiply plus half plus 3 multiply minus half, because 3 electrons are of opposite spin. So we have 5 by 2 minus 3 by 2, that is 1. Now 2s plus 1 is 2 multiply 1 plus 1, that is 3. For L we have 2 multiply 2 plus 1 multiply 1 plus 0 plus minus 1 multiply 1 plus minus 2 multiply 1. So we have 4 plus 1 minus 1 minus 2. Plus 2 and plus 2. So this is cancelled out as this and L equals to 3, that is F. For J, value is L plus S modulus to L minus S modulus, and we have L plus S, that is 4, and L minus S, that is 2. So 4, 3 and 2, and we have the more than half filled electronic configuration, so we take the highest value of J, that is 4. So the term symbol for D8, the term symbol can be written as 2s plus 1, that is 3. So 3 and F, the value of L, and J, that is 4. Now for D10, we will find the microstate as well as the term symbol. So for microstate, the formula is n factorial upon n minus r factorial and r factorial, that is 10 factorial upon 10 minus 10, that is 0 factorial, and 10 factorial. So this is 1. Alright. So the microstate for D10 is 1. Now the term symbol can be found out as 1, 2, 3, 4 and 5, 6, 7, 8, 9 and 10, plus 2 plus 1, 0, minus 1 and minus 2. S is 5 multiply plus half plus 5 multiply minus half, as half of them are of the upside spin and half are of the downside spin. So we have taken plus half and minus half. So this comes out to be 0. So S is 0. Then 2s plus 1 is equal to 2 into 0 plus 1, that is 1. Now L is, as we can see that plus 2 multiply 2 plus 1 multiplied 2 plus 0 plus minus 1 multiplied 2 plus minus 2 multiplied 2. This whole term cancels out and it will become a 0. So L equals to 0 for S. Now for J, L plus S to L minus S. It is L plus S, that is 0, and L minus S is also 0. So J is 0 for this. Now the term symbol for D10 can be written as 2S plus 1 L and J. That is 2S plus 1 is 1. So 1 and L is S. So S and 0. So this is the representation of term symbol for D10. Thanks for watching.